All right, welcome guys to our next session of our AWS studies. Today we are going to be looking about data lifecycle manager. So we are going to see what data lifecycle manager is all about. You discovered that in our last class we created an EBS volume, and then we created snapshots from that volume. We took the snapshot from that volume and we went and created a machine in a different availability zone in the same region. So right now we want to look at how to manage your snapshots. What did we say? We said a snapshot was an image taken of an elastic block storage. So if you have a machine, if you have an EC2 instance like this, and you happen to have an attached volume to that EC2 instance like this, and then you take this snapshot. If you take this snapshot and bring it here, what will happen to this snapshot? The snapshot will have information that was here at a particular time. Let's say if you take this snapshot at a particular time, let's say you take the snapshot at 9 p.m. If you take this snapshot at 9 p.m., the information that will be available inside this snapshot here will be information right up to 9 p.m. What of the information that happened at 10 p.m., at 11 p.m., at 12 p.m.? What of that extra information that came in? It will not be available here, right? So what we are trying to do today is there a possible way of taking snapshots, of configuring snapshots so that they should be occurring by themselves and deleting themselves? Because if you take a snapshot today and then after like 11 p.m. you take another snapshot, after like 12 p.m. you take another snapshot, will this snapshot again be useful? This snapshot has old data, so this snapshot should get deleted. You are now interested with the snapshot with the most recent data, so the snapshot with the old data gets deleted, right? So we want to look for a system that will manage the taking of snapshot and deleting of those snapshots. So we are going to look for a data lifecycle manager that will be taking snapshots automatically and deleting the old snapshot and keeping only the most recent snapshot. That is what we are going to be doing today with respect to snapshots. Okay, let us quickly get into our console and see if we can create a machine. My machine is already shutting down. That's already shut down. Okay, let's launch a machine. Wow. Okay, we were in the context of creating our machine. I wanted to create a life cycle machine. All right. I like Ubuntu. And then I take my key pair. Alright, my security group. Jesus Christ, I am in Ohio. Okay, no wahala, we can practice in Ohio. Then I add another extra volume, which is maybe 5 GB. I create. Okay, cool. All right, now we are in Ohio. We have our Lifecycle machine. This is our instance that we have just created. Okay, and inside this instance we are going to create a snapshot of this volume. This volume of 5 GB, we want to create its snapshot. Lifecycle snapshot. Okay, we have created a snapshot of this volume. Here is a snapshot. All right. After creating this snapshot, what we want to do is, we don't want to be creating snapshots with our bare hands, like go click and create snapshot. No, we want a situation in which a system is going to create those snapshots for us and delete them, and the name of that system is Data Lifecycle Manager. Okay, when you read your notes, you understand what all about Data Lifecycle Manager. So that Data Lifecycle Manager is found in EC2. So you go to compute, you come under Elastic Block Store, you will see Lifecycle Manager. Now you click on Lifecycle Manager, you have options here. You can take EBS Snap Policy, EBS Back AMI Policy, and other that. We are going in for EBS Snapshot Policy. Next, you then come now. Are you trying to take the snapshot of your whole instance or of a volume? I'm trying to take a snapshot of my volume, right? You give the volume name. Now there is something that we have not yet done. You cannot give a lifecycle manager to a volume that does not have a name. So let's go back to our EC2 instance and give our volume a name. If you don't give your volume a name, you are not going to be able to create a lifecycle manager. So I come to my volume and I give it a name. This is my volume. I give it a name, which it should be volume 1. I give that name, I save. Now when I come now to my Data Lifecycle Manager, I'll choose volume. Then this is the reason why I must give the volume a name, because my target source must be reference to that volume name. When I come here, this target source, it needs to be reference to that volume name, and the entry key is name, and the value is, you see, volume 1. That is the value. And then you add. Don't forget to add. If you don't add, this thing will fail, your life cycle will fail. Don't forget to add. Come down, describing your life cycle auto snapshot recorder. I'm just giving something. You can give anything. You can describe your policy with anything, and that is all. When you do this, you go to next. Now we are in next, so you are going to schedule. Your schedule name is what? How do you want to put that particular schedule? Let's just allow it as schedule 1. The frequency of that snapshot will be occurring. Is it daily? That means, are you going to be taking a snapshot every day? Are you going to be taking it every week? Are you going to be taking it every month? So let's take the snapshot every day. If you are taking every day, in that every day, are you going to be taking it every 1 hour, every 2 hours, every 3 hours, or 4 hours? In that every day, let's say we are going to be taking a snapshot every 1 hour. Of course, you are going to have so many snapshots, right? Take that you are going to be taking a snapshot every 1 hour per day. Okay, fine. Let's say if you are going to be taking it every 1 hour, when are you supposed to start? When are you starting? At which time are you starting to take the snapshot per day? I'm saying that I'm starting at 9 a.m. in the morning. Snapshots to start. Mindful that work starts at 8 o'clock. So at 9 o'clock, the first snapshot should be taken. 10 o'clock, another snapshot should be taken. 11 o'clock, another snapshot should be taken. Then retention. This is the power of Lifecycle Manager here. Retention. You can say how old a snapshot stays before it expires, or you can say how many snapshots are going to be there before they start deleting. So let me explain you. If you say count, that means you are talking about how many snapshots should be taken before they delete. I put 3. If I put 3, that means at any one time you will see 3 snapshots. When the 4th snapshot is coming, the old one gets deleted. When the 4th snapshot is coming, the old one gets deleted. I hope you understand what I mean. This is what I mean here. There are snapshots that are coming. At any one moment, we always have 3 snapshots. 1 is the first one, this is the second one, and this is the third one, right? At any one moment, we'll always have 3 snapshots. So what happens when 1, 2, 3? So what happens is that this is the first snapshot that occurred, this is the second one that occurred, this is the third one that occurred, right? So this one is the most newest snapshot. Also, now when the 4th snapshot is coming, if the 4th snapshot is coming, the 4th snapshot is coming here, the 4th snapshot is coming like this, what will happen? This one will disappear. Also, this one like this will totally disappear. This one will go off. So this one coming make this one go off. So at any one moment, we will always have 3 snapshots at a time. Okay, that is the reason why I am configuring the snapshots here and saying keep 3 snapshots at any one time. That is count. Now for age, that means I will say expire from standard tier after how many days, or you can say after maybe weeks, after months, or after years, right? So better you can say expire after 1 day. That means after 1 day, all the snapshots that have been taken get expired. Another snapshot starts coming. Okay, but mostly we always use count in the industry, right? So that is the power of Data Lifecycle Manager. And then I review my policy and I create my policy. Now as I've created this policy, now the policy is created. Now I will not have to go and be doing snapping, doing manual live snapshots. No, the system is going to be doing my snapshots and keeping them for me automatically. So at one time I will just come down to snapshots. The system will be providing me most of these snapshots now automatically. That means at any time that I will come here, I will always see 3 snapshots available here anytime, and they will always be deleting and new ones updating. So that is the power of data lifecycle manager. All right, any question at this level? All right, no question at this level. So we'll go to our second topic that we want to demonstrate today is recycle bin. Look at, we have one snapshot here. If I delete this snapshot, let me just delete the snapshot. If I delete this snapshot here like this, the snapshot get deleted. It has gone. It is totally deleted. There is no other snapshot again that is available like that one. It is totally deleted. So in the normal sense of every programming, there is no way by which you can put delete without putting recycle bin. So today, yes, Declan, you want to say something?
Yes, as concerns snapshot, is it there to give you an update of your information that was previously stored? If you say per count, means after every hour it gives you information, your data as per configuration.
You are taking your snapshot to give you what is snapshot? Snapshot is a backup policy, right?
Yes, sir.
Snapshot is a backup policy. You are just simply taking a backup of your data as it is in that particular time. At that particular time, you are just simply taking up your policy as it is at that particular moment. That is snapshot, right? Because snapshot is just some sort of like a backup. Information that is there in your data center will be backed up in some sort of a snapshot photo. That particular information at that time is backed up. That is a snapshot. So if you say that the information should be backed up every 1 hour, let's say you are some sort of a telecom industry that is receiving let's use mobile money. Do you know how many people are transacting mobile transaction every second or every minute? The transactions are huge, right? So you can configure now the machine that is running, the server that is running mobile money, and tell the server that I want a backup of all the transactions in Cameroon every hour. Now what that server will do is that after 1 hour it will take a snapshot of all transactions that has occurred for the past 1 hour and keep. After the second hour it will take another snapshot and keep. After the third hour it will take another snapshot and keep. Then after the fourth hour, when it is taking now the snapshot of the fourth hour, that first snapshot that was taken gets deleted automatically, because you cannot keep piling snapshots upon snapshots.
Okay, that means for the 5 gigabyte that you configured, it is just okay for it. That means it can never exceed the 5 gigabyte that you configured.
Not like
the volume is 5 gigabyte, right?
The volume of it is the volume that is 5 gigabyte. Take a look at this.
Okay.
Listen, this volume like this, sorry, this volume like this is 5 gigabyte. Yes, we can configure this volume 5 gigabyte, but it doesn't mean that the snapshot is going to take data that is equal to 5 gigabyte. The snapshot is just going to take the volume, the total volume here is 5 gigabyte. When you take the snapshot, right, if this 5 gigabyte had data inside that is, maybe we'll say 2 gigabyte, this is data that is full inside here, and you take a snapshot of this 5 gigabyte, the snapshot, how would the snapshot look like? The snapshot will look like this. You take a snapshot and the snapshot will look like this. This is a snapshot of what you are going to take. The snapshot will look like this. It is going to be the same 5 gigabyte, with what amount of data inside? With a 2 gigabyte data that is inside. You get it?
Yes, sir.
It just simply takes a copy of what was here and bring it here. That is at a particular time, right?
It brings out the copy of the content.
It brings out the copy of the whole content here. Now, after some time, your data has increased in that very this very data. After some time, your data has increased. It is no more 2 gigabyte. The data has increased now to almost close to 4 gigabyte. No, so if the data has increased to 4 gigabyte, the data is now at this level, 4 gigabyte. What will happen? You take another snapshot. This time around, your snapshot will have data that is what? Your snapshot will have data that is, your new snapshot that you are taking now will have data that is equal to what? Your data will be equal, the new data that will be inside your snapshot will be equal to 4 gigabyte of data. This is how your data will be, 4 gigabyte of data. Now look at something here. This snapshot of 4 gigabyte data, this one is having 4 gigabyte. This snapshot of 4 gigabyte of data already contains this one. Is that true? Because the data that was inside here is also inside here. Is that true? Because this one has data of 2 gigabyte. This one has data of 4 gigabyte. That means this one has this data plus an additional this data. Is that true? So
yes,
do we still need this one again?
No.
So that is why you configure now data lifecycle manager, that when 3 of them are already available, the older one is no more needed. It deletes it.
Okay.
Is the concept understood?
It is, yes, understood.
Okay.
So when the data is up to 4 gigabyte, right?
Mm-hmm.
What is left of the 5 gig is 1 gigabyte.
Yes.
Then what? Okay. In case it goes up to 5, what happens? Or it cannot go up to 5.
If it goes up to 5 gigabyte, no problem. You still take a snapshot of it.
Okay. What if it exceeds?
How can
is there a case like that?
How can data exit the container?
Okay.
Is it possible?
But that was my worry.
Because the data, how can data exit its container?
Where my brain is taking me is like, what I'm trying to ask is, what if the data is like equal to the space? What happens?
The problem here is not the data. The problem here is that,
okay, for example, right,
no matter what data is available there, a snapshot will be taken.
Yes.
No matter what data is available, if the data that is available here is 5 gigabyte, a snapshot of 5 gigabyte will be taken. A snapshot is just like, please, okay, let me try to demonstrate a snapshot to you. The idea behind the data that is available is not actually the snapshot. It would not make you understand a snapshot. Now look at what a snapshot is all about. You have a you just take an example, right? You have a, don't look at this like an AWS content, please, because when you are looking at it as an AWS content, you are going to fail. You have a bucket. This bucket is full of maize. You have a bucket that is full of maize, right? And there are people in the farm that are still harvesting the maize. This bucket is full of maize. Now, when we say that there are people in the farm that are still harvesting the maize, it means that what? It means that at any one time you come, this bucket will be increasing. It will be full. If you come, the bucket is now at this level, it is half. This bucket is at half the normal at half the normal quantity. Now, if you take, let's look at the literal part of it. If you take a snapshot of this bucket and go to show to somebody, what would that person see? The person will see a snapshot, a picture of the bucket, which is half, right? If the person takes that picture and goes somewhere and tells the people that they are harvesting corn, and the corn that is being harvested there have been harvested up to half the bucket, and the people want to imitate what you people are doing where you are doing, they will create a bucket and put corn inside, which is half that bucket, right? Is that not true? That is the idea of snapshot. The snapshot is just that it takes data at that particular moment and goes with it to a different site. Now, is it true that at that particular moment when you people are there looking at the picture that the bucket is half, and these people still continue harvesting the corn, is the corn still at half? Technically, no. The corn will already be increasing, right? And if they are to take a new data, they will see a picture, they will get a picture of a data that is increased, right? The new picture will have data that is increased. So what will happen? As the data keeps increasing, a picture is being taken. So now we are trying to create now an automatic system that takes data without somebody manually taking it. Since we know that data is something that is dynamic, it keeps adding. So forget about the container here, because most often they will use EFS containers that will expand forever, or they will use S3 buckets. We'll come to S3 buckets.
Wahala. So that is what I wanted, because now, do you know where my worry was coming from? Because you are setting an example of EBS, and we know that EBS is static as compared to EFS, that is elastic, right? That's what I was trying to bring it, but now I understand.
Even if it gets full, there's no problem. The data will still be taken as it is in a constant way now, because it is already full, and your snapshot will keep taking one and the same type of data, which does not make sense.
Okay.
You get the idea? All right. So we were saying that when you delete your snapshot, it disappears forever. But we do not want it to disappear. That is why we have brought in the idea of recycle bin. We want that when you delete, if you happen to delete your data, it should first of all go to the recycle bin before it is being totally deleted. Generally, as a programmer, you should know that humans always make mistakes with deleting things. So you should never program something that when it is deleted once, it goes forever. No. Program it that if it is deleted, there is a way by which you can go and fetch it back from the dustbin. And in AWS, the dustbin is not configured by default. You are the one that goes and configure it, because the dustbin is payable. The amount of time that your dustbin runs and the content of the dustbin is payable. So if you want your data to be kept in the dustbin, you come to recycle bin. When you come to recycle bin, they'll ask you to create a retention rule. You create keeping my snapshots. You can copy the same thing for your description. And paste them, and then select your resource type. What do you want to be keeping inside that place? You want to be keeping snapshots, right? And then you want to keep for how long? You want to keep for as many as, maybe let's just say keep it for 2 days, after which it gets deleted totally. As far as resource type and match, it doesn't too much matter. And then you create your rule. Name, the resource tag is always your name. Value is always your EBS. You can give anything, you can always give anything there, anything whatsoever. What? I did not give my EBS a name. Did I not give my my snapshot a name? Okay, my snapshot was not existing, so let me create a snapshot. What am I doing? Take the volume. This is the volume. Give it ABS 1. That's the name of the volume. Okay, let me create a snapshot from that volume now. Snapshots volume. I create my snapshot. Okay, my snapshot has been created, so I can go to my snapshot. I can see my snapshot. Give a snapshot a name. First snapshot. Write it down. Now I go to my Lifecycle manager. My name, and your snapshot now comes here automatic. You see the name of your snapshot, it comes. So if you don't write the name of your snapshot, it will not come out. First snapshot. Then you add, always add. Then you create now your snapshots. Your retention row is created now. This is your retention row. That means that what? Your recycle bin is now functional. Your recycle bin is very functional now. So as your recycle bin is functional, let us go and delete a snapshot, and then we see what happens there. We have this snapshot here. Let us delete it. We delete our snapshot. Our snapshot is deleted. Now as our snapshot is deleted, we come now to our recycle bin. where can we see that snapshot in our recycle bin? Come to resources. Under normal circumstances, our snapshot should be found in our resources. Okay, we create another snapshot. Create another snapshot from the EBS volume. I come down to snapshots. And we see our snapshot is available here. Okay, let us check our retention rule. Is it there? Does it pick our snapshots? All right, our rule is there, and it actually picks our snapshot from our resources. Now we go to our snapshot. Let's delete it. Before we delete it, let's give it a name. Second snapshot. Cool, we have a second snapshot. Now we refresh. Let us delete this snapshot. We have deleted our snapshots. Let us see if we have the resource in our resources. Still I cannot see it. Retention period 2 days. Keeping snapshots. Alright, we have our first stack here, but where is it here? So I've been we have been trying to get back our deleted snapshots. So normally this is what happens when you come to your lifecycle policy, your retention policy at the level of recycle bin. When you come to your retention policy, you're supposed to come to your resources here, and then you are supposed to see the deleted resources here. And then if you want to recover it, you are supposed to click on it, and then you come to recover. So I will find out and see what is actually not being configured rightly at the level of the recycle bin. Let's go ahead to our last topic of the evening, which is Amazon AMI, Amazon Machine Image. We are going to demonstrate Recycle Bin tomorrow, if there is a class tomorrow, because I'm really busy tomorrow. Okay, let's look at Amazon Machine Images. It's very important. Amazon Machine Images, very important. Okay, what is an AMI? What is an Amazon Machine Image? Generally, when we are creating our machines, when you are creating your machine, you always come here. Please, I still repeat, when you finish practicing, always delete. Always delete. Delete everything when you finish practicing. Don't allow it that I had this euphoria that when I created my things, I will be loving them, and then I will be keeping them, that let me keep them for some time and see how they are functioning. If you keep your things like that, guys, they are going to cost you money. Always delete. When you finish, always delete. Delete your volumes, delete your EC2 instances. When you finish practicing, always delete them. Everything that you create must be deleted. If you don't delete it, it is going to be compiling on your card. I've already destroyed more than 3 accounts, and there are some of you here that are already crying that their accounts have been blocked because they are not deleting issues. Always delete. I keep saying always delete. When I say like that, people will still come and contact me and tell me that I forgot to delete. Always delete. Alright, I think I have deleted mine, remaining the last volumes. My volumes now can get deleted. This volume is attached to a machine in North Virginia. I knew it. I have to first of all delete the instance. You see, especially when you create instances in different availability zones, when you create instances in different availability zones, you can forget that in a different availability zone you had your instances created there, and you need to delete those instances. Now when that happens, those instances get functional and they keep moving ahead. So you have to make sure that you delete all the instances, all of them, please. Okay, completed. I still have an EBS functioning here. Why did I press? I'm taking out time like this because I know that some of you are going to burn your accounts in the name of not being capable of deleting, so that you should see how the various steps on how to delete, because when you will be deleting, you will be also facing all these issues that I'm facing. My volumes all have been deleted. My snapshots, 2 are still remaining. So you see, you can do like that and you think that you have deleted everything when things are still available there. Make sure that everything gets deleted. Okay, these snapshots are still available because the machine in Ohio is still functioning with them. I have my machine there. Okay, let me not waste your time, and we keep moving ahead. Today we want to talk about Amazon machine image. When you want to create your machine, each time that you want to create your machine, you always go and select the image that you want to use, right? Each time any of you want to create your machine, the first thing you do is you always come here like this, launch instances. Then you come here, you select the name of your machine. Let's say AMI machine. That's the machine that you are selecting. Now if you select this machine, you are going to come here like this, and then you are going to select your particular AMI. These things are called Amazon machine images. Let's say I select a machine like Ubuntu, an image like Ubuntu, right? If I select Ubuntu, this is the image that they are giving me. This is a particular AMI ID that I've been given. This one like this is my AMI ID that I'm being given. Now with this AMI ID, I want to use that particular AMI and actually configure my own AMI. So why will I configure my own AMI? Why do I want to configure my own AMI? Come over to this demonstration board, please. Now look at something here. Netflix alone uses more than 10,000 machines, 10,000 EC2 machines. That means Netflix alone uses more than 10,000 EC2 machines. And if they ask you to create one EC2 machine saver for Netflix, this is how one saver for Netflix is. One saver for Netflix is there, and then the first thing that is installed inside that saver is a Java runtime environment is installed inside that saver. Maybe Docker is installed inside that saver. Maybe Kubernetes, the Kubernetes cluster is installed inside that saver, and then maybe let's say Terraform is installed inside that saver. Ansible is installed inside that saver. All these things are installed inside the saver. Let's say we have almost close to 5,000 machines that we are going to create and install all these servers inside, all these running operating systems inside. We have 5,000 of those machines. You are an engineer, a cloud engineer. They have told you that they need you to provision 5,000 machines in North and Central Africa, and inside those 5,000 machines you need to install all these operating systems. Tell me, will you go install this one, go create another machine, install another one, go create another machine, install another one? It is impossible. Or will you create the 5,000 machines at the same time? Because we know that there is a possibility here, look at here, for you to multiply those machines. You can multiply those machines here and just write that, okay, create me 5,000 machine, right? You can write it that it should create you 5,000 machine. It will create you the 5,000 machine, but will these programs be inside? Will all these programs be inside those 5,000 machines? No. That means you create 5,000 machines before you start installing all these programs, right? So with the idea of AMI, the Amazon machine image, we are going to create just one machine like this, and then we install every operating system that we want to install inside that one machine. We install all operating systems that we want, all functional systems that we want inside that machine. The Docker, the Kubernetes, the Ansible, install everything. When we install everything now, we'll keep it now as an image, and then now we'll start creating now new computers from this one already created. We can now spin off 5,000 computers from this our image that we have already created. Is that clear? That is the idea of AMI. So let us actually see it in motion. So we first of all create a normal machine, create a normal Ubuntu machine, and then I come down. Let me go to my duty station. I am still at Ohio. Let me go to North Virginia, please. Okay, I create AMI machine, come down, Ubuntu, get my key pair, after I take my security group. The next thing is, let me make it a saver. And put a bootstrap. Let us consider that the various applications that we are installing are bootstrap. Let me put a bootstrap. Where is that? Our bootstrap script. It's our bootstrap script. Let's take it. Okay, this is what will be written in our bootstrap. Please, let's put what will be written in our bootstrap. Machine is okay. All right, we launch our machine. Only one machine. We have installed our saver. It is okay, so we launch our machine now. Fine. Let us make sure that this machine is having machine is still to come on. Okay, it is running now. The security network of this machine, this is its security group. For simplicity's sake, let us open all traffic, because if we do not open all traffic, we will not be able to enter this machine. So how do we open all traffic? Edit inbound rules, and then we add a rule here. Now we can say all traffic, all form of traffic now will be, and then we custom it from anywhere. So all form of traffic now will be available inside this machine. We save the rule. Our rule is saved. Now we knew that we have configured a web server. So in order to access that web server, what should we do? We should take the IP address of the server, right? Let us take the IP address of the server, the public IP address of the server, and then we see whether we can have our website that is available. Our website is not yet running. I'm wondering if it is actually the machine that I created. I thought I created a machine written AMI machine. Alright, fine. We'll enter the website after. Now we have created this machine. Let's consider that we are here. We have created this machine like that, and we have installed all these things inside, right? Everything is installed inside. Now we want to move this machine over to, first of all, we'll transform it as an image. Transform this machine as an image. How do we do that? Look at, we take this machine, we come to actions, we come to image and templates, we take image and templates, and then we create an image from this machine. Create an image from that machine that we have just created. We create an image. We give an image name. You can say Netflix image. Description: having all software. That means this image is having all software that is needed, right? You can add an extra volume to the machine. You can add extra volume to the image that you want to create without any problem. So with that, we create our image. Our image gets created. Where do we see the image? The image is now well created, but where do we see the image? Here is the image. It is available here. Images. So this is the image. This is your image that you have created. New image, Netflix image. Okay, this is your image that you have created. So this image now, like this, you can now from this image create now 5,000 machines. So I can click now on this image now, and I go to actions, not actions, I go to launch instances from AMI, right? I can now launch an instance from this particular image. Not so, and then here now I can put now my 5,000 machines. If I put now 5,000, there will be 5,000 identical machines created that have all these applications inside. 5,000. So that means you create one machine with all the applications inside, you turn that machine into an image, and then you create now 5,000 machines from that particular image, right? So what is another importance of this image? I'll not create a machine, please. From here you know what to do. You know how to create a machine. You know how to create a normal machine. I'll not create a machine. So what is an importance of this image again? You can take this image to a different availability zone. I can copy this image like this, copy to a different availability zone, and in that availability zone I will create another machine from it. It is not possible for you to take a machine from one availability zone and go with it to another availability zone. But how is that possible? It is possible to transform the machine into an image, take the image from that availability zone and go with it. So in a nutshell, this is what I'm saying. This machine like this is a machine that has been created, but I want this machine in this availability zone here. This availability zone, the machine is found in one availability zone, but I want it in this availability zone here, this other availability zone. So what do? I take this machine that I've created, I change it into an image. I change this machine into an image. This is the way the image look like. I change the machine into an image. Then I take now that image, I bring it now to this availability zone. In this availability zone, I can use now that image and create the identical machine, right? I create the identical machine now, but it is not possible for me to just carry this machine and bring here. It is not possible. This one is not possible. Changbat. You have to take the machine, turn it into an image, bring the image to this zone before you create a new machine, right? So this is what I wanted to demonstrate here, that you copy the AMI that you have transformed. That is the image that you have transformed. If I click copy here, the image will be copied. Now I come here, I decide which region do I want to create a machine in. I want to create a machine maybe in let's remain in the United States, land of everybody's dream. I want to create a machine in, let's say, North California. Now I come to copy AMI. That AMI has been copied to North California directly. And when I will go to North California, here I am in North Virginia. So if I just click and I go to North California, US West is North California. I see it directly comes to North California AMIs, directly come there, and I see the AMI in North California, right? Look at where I am now. I am in North California. Now I can click the AMI from here and I launch a new machine from here. Okay, that is what you do. That is what you do in order to create a new machine. Okay, so is there any question? That is what you have about AMI, and that is the use of AMIs. All right, in the absence of no question, Mr. Walters, your hand is up, sir. Okay, in the absence of no question, let us end the class and we continue tomorrow, God willing. Good night, everybody.